Hello Year 7. So this is a video helping you to understand what you need to do if you choose to do experimental research for Science Talent Search this year, 2021. This can be one of the most challenging projects for you to do, but it can be one of the most fun as well. So don't let all of this information deter you. Watch through this video and go from there. So the most important thing to do is choose an area or something to experiment on that is of interest to you and matches your skills. Now it's important to note that these experiments are done in the home environment. It's not as limited as that sounds, and your teachers can help support you with choosing an experiment that can work really well at home and give you some good results. The classroom time that you have allocated will then be very useful in you writing about planning your experiment and writing about your experiment. But as I said, the most important thing to do is to choose something that you're interested in and choose something new and novel. So it's not a good idea to just repeat an experiment that's been done many times before and can be found easily on the internet. The judges are really looking for something that's new or improves on an experiment that's been done before, or has some special meaning or way of supporting the community, so therefore has some kind of relevance in society today. So you might improve on something that already exists by redesigning something and then testing it to see if it actually meets the requirements. So for an example of this that's been talked about before, but I don't know if it's been done before, is testing a new style of egg box to try and stop food wastage or deal with the issue of food wastage and stop it getting broken in the supermarket or in transport. So that requires some engineering and structural sort of building work around the eggs and then testing it many times to see if the new improved design actually does protect the eggs more effectively than the traditional egg boxes you find in the supermarket. Another idea that has been investigated previously, it might help you to think about some of these things yourselves, is about testing detergents and how we can get stains out of clothes. Now this particular student used a number of different typical stains that you might see on a washing ad or you might find on your own clothes, such as egg and chocolate and ketchup, and then used a range of different products to see which one was most effective at removing the stains, and then looked at why that might be. Now, to put a bit more of a, sustainability slant on that project, you could look at more natural products rather than chemicals from the supermarket. So you might look at some chemicals that you have in the home, such as lemon juice and vinegars and just basic soaps and bicarbonate, all sorts of things that you might have in the home that might be able to remove stains without the use of heavy chemicals, which potentially could be better for the environment. So they're kind of tests that you could do. You could also conduct an experiment that has been done many times before, but in your own way. So things experimenting on pineapple and how pineapple affects gelatin is one possibility for you to look at and potentially improve on and extend. So there are a few ideas that have been suggested in the past and that you might be a good platform, but I'm sure your teacher has many more ideas to share with you if this is a topic that you're interested in. So don't just necessarily think about an experiment that you have done or have heard about in the laboratory. Think about testing or improving devices as well. So when you're doing this, you do need to keep it novel, you do need to keep it interesting, but you also need to keep it conventional. And what I mean by that is it needs to follow a conventional scientific method. Okay, so what we do usually, you come up with an idea and you might look into some resources or into the internet to see if this has been done before and whether you need to modify it or whether that gives you a different idea. Then you need to make a prediction. We call this the hypothesis. I'm sure many of you already know how to construct a hypothesis, but that's the starting point for your project. You make a prediction about what outcomes you might find, and then you write a method that is highly reproducible, so can be done over and over again. It's written in very specific language, and that gives another scientist instructions on how to conduct your experiment. Within that method, you need to clearly describe what you're going to change and what you're going to investigate. And also, very importantly, you need to explain what you're going to control. So therefore, the things that you're not going to change. And we call those the controlled variables. That ensures that your test is a fair test. So there's some of the things that you can think about and talk to your science teacher about in the classroom. Recording your experimental results will need to be in a table, and then hopefully you'll be able to graph the findings from your method and present the information very clearly in a scientific report. And then once you've done that, so once you've constructed a hypothesis, you've written a method that can be followed very easily and reproducibly, then you have conducted multiple different trials to just prove that your findings or your results aren't just a one-off, they keep happening over and over again, so they can be relied upon. Then what you need to do is plot your data and discuss that data. And that's in a discussion and then finally in a conclusion. And all of this, as you'll see in the document, has to be written in a scientific report. Okay, so you'll find this in your Science Talent Search booklet. The one thing that you might not have met before is this thing called an abstract, and it's the thing that and usually it comes first, but we actually write it last. It's a summary of the idea of the project, how it was done, and what was found. So it's an overview of everything. Then you introduce the project, you write a very clear aim, so the purpose of your investigation, and then you'll describe the materials you've used, how you conducted the experiment. A very important step is doing the risk assessment, and your teacher will show you how to find the example risk assessment, which is on page 23 in this document. Describe your results and observations in a written report, discuss those and explain why you think the results were as they were, and then draw a conclusion which ties everything together. It's very, very important that you learn how to acknowledge your sources and produce a reference list, which you might have previously called a bibliography. In this document, you'll find some advice on how to do that. And again, your teacher can direct you towards that. So all of this needs to be produced in a Word document and saved. I would save it in a number of places. One would be on your OneDrive and another on your desktop or on USB. And then we can submit that electronically as well as print off a paper copy for submission. Is there anything else I need to explain to you? I think that covers it. Please, if you are interested in doing experiments, have a conversation at home about the fact that this will be conducted in the home environment, so it will require some at-home work, and not just once. Experiments are always done multiple times. So your parents need to be happy for you to do that. Bring your ideas to your teacher and discuss in the classroom. Find the rubrics in the student resources section in Teams and have a look at the rubric and how this is assessed. And good luck!